Okay, next we will start. We were doing the fourth question at the page number 166. Now see here, what is given, frequency is given, and then distance is given. So first you have to read full statement, then you have to find out what is given and what you have to find out. Sometimes they are giving extra information, like in this question they have given distance, but we don't need any distance. Frequency is given, they are asking about the time interval between successive compression. Okay, so successive compression we can like relate with the crust of the wave. So frequency is given, okay, and then what is the formula of time period? First formula 1 by nu. So nu is given, put it here, and then you can find out the answer. Now I was talking about the another formula. Okay, see what is another formula of frequency. Frequency, another formula is number of oscillation by time, and when you will make it opposite, it will be the formula for time period. Okay, so t by small t by number of oscillation. What is small t? Now think about it. If I will give you 1 point, from 1 point how many waves are like passing from 1 point within 1 second, that will be the time period. Okay, time period. And if I'm talking about 1 second, so 1 second will be the time interval. Okay, so that is, and number of waves 20. Suppose 1 point, I'm giving you 1 second, from in 1 second how many waves are passing? 20. So 20 will come downside, 1 second will come here, and then you can find out capital J. So that is the thing. Now the next question is 166 third. The loudness and intensity difference I have already given you in the note. So loudness, intensity is how much will be the actual volume of the, suppose one sound speaker is there, so how much actual volume of the sound is coming, and what is your response, your ear's response, that will be loudness. Okay, now the next question is here, in which of the three media the sound is fastest? Now see, I have given you in the notes, there are two factors that is like affecting the speed of the sound. That is, first factor is what? The speed of the sound, and second factor is the medium. So in the solid that we are doing from the last class, in the solid the particles are very close. So when the particles are closest, it will be easy for the energy to pass on. So in which medium it will be fastest? Solid. Okay, so you can see here the first question that I was talking about, loudness versus intensity. You can see here I have given you the table here, and this question is here. Okay, so you see solid, maximum, liquid, and gas. So in this question, which one is the fastest? The question, which one is solid here? Iron. So which one is the fastest? Iron. In iron it will be fastest. Now the next question is, and echo is heard. So echo is there, sonar is not there, so echo is there in your syllabus. So echo is heard in the 3 seconds. Okay, so what is echo? See, one wave is going here, there is one wall, it is hitting and it is coming back. So 3 seconds is given, it means it 1.5 seconds is going, 1.5 second in coming. So total time is given, that is, you have to understand. So 2 time it is passing. Now what is the distance of reflecting surface from the source? When the speed is given, then time is given, second is time. So they are talking about the distance. Okay, so distance, what is the formula of speed? Speed is equal to distance upon time. Now here distance is a 2D, because echo is like traveling. Echo is what? Coming of the wave and then like returning back. So 2 time it has to travel. Now see here, the same I have given here. So this is see, time is given 3. Okay, so if you want to talk about the distance, either you can do 2D by t, or just in the starting you can do, time is 3, no, so you can just do 3 by 2. So half time we will take, because half distance it is, if it will go 1 time, that will be the time interval, and that will be the distance. Either you just take 3, either you can do like this, s is equal to 2d by t. So 2d, so 2d is equal to t into s, so d will be t into s by 2. Either you can do like this or you can do like this. You have to understand the concept. That's why I have done this. Otherwise formula I have given you, that if echo is given, then you have to apply this formula. Okay, this formula 2d by t. I have already told you, if reflection is given, if echo is given, then 2d by t you will do. So you just apply this formula 2d by 2. So d is coming to t into s by 2. So t is 3 into what is s? S is 342 by 2. You will find out it will be coming like same 5 and 3. So solve it. Either you just apply your mind if you understood the concept, otherwise just memorize the formula. Okay, whatever is comfortable for you. Now the next question is, why are the ceiling of concert hall are curved? Okay, so I have already told you, in two situations we are increasing the reverberation. In the topic reverberation we have done this. Okay, so why the ceilings are curved? To decrease the reverberation. So I have given you there already. So 2 in 2 we are increasing, in 2 we are decreasing. So curved ceiling we are decreasing. Okay, so one wave only hit one time. Okay, if it is straight, it will hit many times. If it will curve, it will hit one time. So one time reflection, so you will hear only one echo. Otherwise the voice will be like it is hitting many times and you will hear many voices. One person will be talking and you will hear so many voices. That will be confusing. That's why we have to decrease the reverberation. Now the next question is, you just come here. Okay, this question, the page number 170. What is the audible range? 20 hertz to 20,000 hertz. That is audible range of the frequency. Okay, we have already done what is infrasonic, lower. What is ultrasonic, higher than your audible range. Next one is, what is the range of frequency infra and ultra? We have already done. So you will write down from the notes. Infra and ultra we have done the frequency. I have even given you here also in the table. So infra less than 20. These are two. Okay, two extremity, lower and higher. If it is lower than 20, this is audible sound. So it is infra. If it's greater than 20 kilohertz, it is ultrasound. Now the next question is, sonar is not in your syllabus. Okay, next question is, okay, this is sonar. So this question is not in your syllabus. If you have purchased a new book, this will not be there and this will not be there in your syllabus. So this and this, sonar. Okay, next question is, what is sound and how it is produced? I have given you in the I have given this in the notes. So what is sound? Sound is energy produced by, how it is produced? By the vibration of the particle, vibration, this, or oscillation, this if it will go like this, it is oscillation. If it will go like this, vibration. So you will just write up vibration. Okay, then describe with the help of a diagram how compression and rarefaction are produced. For compression and rarefaction diagram I have already given. So you will make the diagram, compression and rarefaction diagram. It's there. Okay, compression and rarefaction diagram. This is the compression and rarefaction diagram. Next question is question number 3. Cite an experiment to show sound needs a material medium for its propagation. Okay, for this we will write page number 162. Okay, wait, 162. Okay, this one is the sound needs a medium, but actually it is not given in your syllabus. That's why I have not explained it. But still, you can sound needs a medium to travel. You will just write down this experiment. Okay, you will write down because it is not in the syllabus. So you just you can delete this question. I don't think it will come, but still you just write if, because it is need a medium to travel. It is not in the syllabus, but okay, so just leave this question. It is not in your syllabus. You have to understand that it needs a medium to travel. Now, why sounds called as longitudinal wave? Why sound waves are called as longitudinal wave? Because the definition of longitudinal wave is what? Longitudinal wave means they are moving in this particle is moving along with the direction. So wave is going in this direction. The particle is also going in this direction. So both are, wave and particle are parallel. That's why sound is longitudinal wave. Okay. So that is it. Now next, okay, if you want to know what you have to write on question number 4. So you have to just draw this diagram. Okay, question number 4, you have to draw this diagram. Okay, move here, this one. Okay, this one, this diagram. So particle is also moving in this direction, wave is also moving in that this direction. This type of wave in the science is known as longitudinal wave. As sound is moving like this, that's why it is also known as longitudinal wave. So the next one is which characteristics of the sound helps you to identify your friend's voice while sitting with the others in dark room. So by the pitch means what? The frequency, how many waves it is, like one person is producing. So it can be deep or it can be deep like a boy's voice, or it can be sharp like the girl voice. Okay, so with the pitch and loudness also, both like comparison, so either sharp, loud, deep, or weak. So these four things are present in loudness and pitch. So how you can find out whose voice is whose? So loudness and pitch, so you will find out, because you are hearing them every day, you are hearing your friend's voice. So some are having loud voice, some are having sharp voice, some are having weak voice. So in this way, so which characteristics are helping you? Loudness and pitch. Next one is flash and thunder are produced simultaneously, like they are talking about the storm. So when storm is there, flash, light you can see, thunder means some sound you will hear. So they are saying the sound you will hear later, but flash means light you will see early. Why? Light will come to you earlier. Why? Because the speed of light is higher than the speed of sound. That's why in this equation you will write down the speed. So the speed of the light is 3 rose 10 to power 8 meter per second, but speed of sound is 340, means it is 300 only. If you will like make it like approximation, if you will do approximation here, so it will 300 around and 350, and it is 3. After 3 you have to find out, make 8 zeros, here only 2 zeros. So which one is higher? Speed, light. So light will be, it is traveling faster. Now the next question is a person has hearing range 20,000 hertz, normal range. What are the typical wavelength of sound waves in the air corresponding to these two frequency? They are talking about this frequency. See, this is frequency. They are talking about what will be the wavelength of these two. What is the wavelength of this? What is the wavelength of this? So two wave they have given. One wave is having 20 hertz frequency. Second wave is having 20 kilohertz frequency. So what will be the wavelength of these two frequencies? So speed of sound they have given already. Okay. So which formula will you see? Frequency is given, speed is given, they are asking wavelength. So V is equal to nu lambda. This formula you will use, because speed is given, frequency is given, they are asking about the wavelength. So see for case number 1 and case number 2. So frequency number 1 is 20 hertz. Frequency number 2 is 20 kilohertz. Speed is given, both the same. Okay, speed 20 kilohertz means 20,000. Okay, so apply the formula and then find out the answer. So you will find out the answer. Only put the value. Okay, wavelength you have to find out. V 344, here 20, here 20,000. So you will find out the answer. Okay, see, if it is coming 172 by 1000, so you can like change it into like this. Otherwise write down like this, it's also fine. Okay, next one is question number 8. Two children are opposite ends of two children. One aluminum rod is given. One child is sitting here. One child is sitting here. One child is sitting here. One strike the end. Okay, so one person is hitting that rod with the stone. Find the ratio of the time taken by the sound wave in air and aluminum of the time taken. They are asking about the time, and now you have to find how one wave is reaching you. You have to find out. You have to find speed. If the speed is higher, then it will reach to you faster. Okay, so ratio of time you have to find out. And now distance. See, the distance for both the like in air and aluminum, it will be same. Why? Okay, think about it. If one aluminum, suppose this is the aluminum This is the aluminum rod. So one person is here, one person is here. So he has his ear is here. So he is listening and he is hitting. So he is hitting it with the stone. So what happened? So wave will start. Okay, because vibration will start in this solid. When vibration will start, one wave will like travel in this aluminium, and some wave, because it is like vibrating now, so energy is passing here in the air also. So in the air also the wave will pass. So we are talking about what will be the time. One wave that is going inside this solid and one wave that is going inside this air. So what will be the ratio of time? Who will reach at this ear faster? So see, the distance is same for both. Time will be different, and time will be different, speed will be different. So we will find out. This is the numerical. Now see here. So in your book, the speeds are given. See, the table is given. You will not find, like, learn, because they will give you in the question. See, speed of the sound is given in the air. Speed of the sound. See, aluminum is given 6420, and air it is given 346. Okay, 346 here and 6420 here. Both the speeds are given. So find out the ratio. See here, aluminum and air. Okay, so two pieces are there. One is here, one is aluminum. So length is same. Length is same for both. Okay. Now speed, this 6420, this 346. Suppose time, distance is, see, speed is distance upon time. You have to find out time. So find out the formula of time. Now x by 4. This, see, time is like same. No. So time is different. This is t1. This is t2. And now x and x, because this distance will be same. So now see what you have to do. T1 is this, T2 is this. Now they are asking about the ratio of time. First find out the time for both. Now ratio of the time, T1 by T2. So T1 on the top, T2 downside. So when you will solve it, x by 346 by x by 6420. So this will go on up, 6420 will be up, x will be downside. Now x by x, it will cancel out and you will find out this. Okay.